So here's what we're going to talk about. We're going to just give a brief idea of what a PDS label is for people who've never seen one before. We will talk about the pieces that are in a PDS4 label. And I should probably explain those terms. PDS, Planetary Data System, has been around forever. PDS4 is the latest version of, I guess, what you would call the archive system. The PDS4 labels are the version that we use currently to design the archive. So I'm going to probably use those interchangeably. What I don't want to say is PDS3. That's the old version we don't talk about anymore. So wherever it's PDS4 or PDS, you can assume they mean the same thing. We have a couple examples, one real life example that I'll show you and one that is just a draft. In part 4, we will talk about those 4 pieces of a label for a science data product and go into them in great detail. In number 5, we will talk about what you do with a label once you've got one. And then at the last slide is references for where to go for more information. Okay, let's just jump right in. What is a PDS label for? It's mainly a unique identifier for a data product. Data product is, think of it as a file, just a file of some collection of data. Could actually be multiple files, but we'll keep it simple. And you want to be able to uniquely identify that version of that product. You also want to know the context of the product, what instrument collected it, what spacecraft was it on, what mission are we talking about, what planet are we at? That kind of thing is called the context. The metadata for this product, those are all the journalist questions: what, when, where, how, why, and by whom was this data collected. We also want to know from the label, how do you actually get into this data file and read it? What is the format? What's in there? If it's a table, what are the columns and what do they mean? If it's an image, how big is it? What is the data type? That kind of thing is also described in the label. So these labels are both software readable and human readable up to a point. You may not think so when you first see one, but it does grow on you. But software readable is the main thing. Then similar products have similar labels. That is, you can expect to see about the same kinds of things in all image labels, about the same kind of things in table labels. All the labels for a given instrument and data type will look similar. So once you've learned one of them, you can apply that knowledge to all of them. That's what the label's for. Okay, I'm pausing for questions. Good, because we got a lot to cover here. So again, we're at the kindergarten level for PDS4 labels. First thing to understand is XML, which stands for Extensible Markup Language. And it's that stuff in the box there. That's a made up example, just, kind of a silly one. But to show you what XML can look like, it's kind of like HTML for web pages, if you know about that. It is software readable and human readable. And the big thing about XML is it is controlled. There is basically dictionaries, schema, that define what the pieces are for and which ones you have to have and which ones are optional and so forth. So if you look at the example, this is about movies. Somebody wanted to label a movie. This is an actual movie, by the way, starring Ronald Reagan and a chimpanzee named Bonzo, who does not get a credit here. So a tag in this vocabulary is a thing inside angle brackets. So movie here is a tag, title is a tag, and so forth. An attribute is the lowest level tag that you can have. So these things, title, first release, director, screenplay, story, starring, those are all attributes, and they belong to a class, a group of attributes. It's called movie. So that's just the terminology, classes and attributes. You can have nested classes, I think as many as you want. Our convention is that we capitalize the name of a class and we use all lowercase for the names of attributes. Okay, so let's look at a more realistic example. If you're looking at a PDS4 label for a science product, they all look like this, but there's some ellipses that get filled in. There's this line at the top that's almost always exactly like that. There's some other lines that start with question mark XML that go into what looks like a lot of gibberish, and I'm not going to explain it now, but I will explain it in a slide further down. But the important part is this product observational class that's in the rest of the label. That's the important part. Product observational is the name of the class we use for science products. There are other kinds like product document or product browse, but we're really focusing on science products today. It has these 4 subclasses in it: identification area, observation area, reference list, and file area observational. And I'm going to talk about each one of those things in turn in a lot of detail. For an example, we have a couple things. I'm going to move this slide out of the way so you can see what's behind it. So right here, I'm looking at my editor for XML. I use an editor called Oxygen. That's what we're going to be using. So the one on the screen right now is a real label for a Mars 2020 PIXL image. And I got all these, you see these are the 4 areas I just mentioned. I've got them all closed up so that they're not overwhelming to look at first, and then we will gradually open them up and see what's inside. In the other tab here, I have a draft label that we've been working on. And this one is actually a draft label for a Viper nervous instrument image. When I first did this tutorial, it was for Viper, and we just picked a Viper nervous data file, which is this one over here, and we made a label for it. So those are the examples I'm going to be using. Okay, we'll go back to, we will periodically come back to this picture so we can remember where we are. And I'm going to talk about each of these 4 areas in turn. They are required to be in this order in the label, but I'm not going to tell you about them in this order. I'm going to save the hard one for last. Observation area is the hard one. So we'll do the easy ones first and get them out of the way. So identification area answers the question, what product is this? And in order to tell you what product it is, we have to talk about logical identifiers. So there will be a slight digression for 2 slides while we talk about logical identifiers. Every PDS product has a logical identifier, or a lid, and a version identifier called a vid. And when you put them together, you get a lid vid. And here's an example. This is the PIXL example that I was just talking about. They all start in PDS. They all start with URN:NASA:PDS. And then the rest of it depends on what mission, collection, and product you have. So let's go ahead in this order. Remember last time we had this group meet, we talked about bundle identifiers for the CLIPS missions, and we agreed that we would use the NASA task order numbers with CLIPS appended or prepended, I can't remember. We agreed on what the scheme was going to be for bundles. So for Mars 2020, we did a similar thing. We agreed that the bundles would all start with Mars 2020 and then an underscore and then the name of the instrument. So this is the PIXL bundle right there. And there's a colon for a separator. And then inside this bundle, there's a whole bunch of collections. The one we're looking at right now is a product from the raw spectroscopy collection for PIXL, and that's its name, data_raw spectroscopy. That's conventional to start with data if it's a data collection. And then finally, this long string underlined in green, that is the product ID for this particular PIXL product. And you'll notice that it looks a lot like a file name because it ends in .csv. And in fact, it is the file name for this product. And that is conventional. You often use the file name to be the product identifier. You don't have to, though. They chose to do that, and they chose to keep the extension as well. And this is 2 colons right there at the end, and version 2.0. This whole thing together is the lid vid. And what do you do with it? Well, it goes in the identification area of the label, and it's split back into 2 pieces. Logical identifier has the lid, and version identifier, version ID has the version number right there. And there's also a title and some other stuff you can put in there. But that is what the identification area is for, mainly. Any questions? Okay, good. That was an easy one. So I'm going to, again, move my slides out of the way and show you what this looks like in that Viper nervous label in the identification area. Here is that label. I hope you can see this. I can make the print bigger if it's too hard to see. But opening up the identification area, there you see, here is the logical identifier that we made up for this nervous image. And it's got URN, NASA PDS. Here is the Viper bundle name. Here is the nervous collection name. And here is the nervous product identifier. There is the version identifier. And here's the title. And another thing that you can have inside identification area is modification history, which is basically the history of updates to this label. There's always one. If you ever have to update this product, you add a modification detail here and explain why you modified it. That's pretty much it for identification. I'm going to close this back up and go back to the slideshow, and we will continue. So the second part that we're going to talk about is file area observational. This is the part of the label that actually describes what is in the file. Well, how do you read this file? So let's take a look at that particular file. This is an example that the Nervous team gave me to work with. This is not real data, but as close as they can estimate to real data. And you can see this is just a CSV table. It's got fields separated by commas. It's got the first row has the headers for the columns. And if you can see, this is a very wide file. If I slide along here, you can see that the headers at some point become just numbers. So these are band numbers for spectral bands. And they go, I'm going to slide some more. They go all the way out to 1199. There are 1,200 spectral bands in this file. And those are the column headers for 0 to 1199. You can see the data that's in here is just, boring stuff. So how in the world do you label that kind of thing? I'm going to switch over to my editor now so we can see what that looks like. I'm going to open up this file area observational class. You see it's got these subclasses in it. The first one is file. It has the name of the file. It has also a local identifier, which is not the same as the logical identifier we talked about before. Local means local to the label, and you might need to refer to this local identifier in other places in the label. That's kind of complicated. It depends on dictionary stuff that you use. So I won't really go into it now and confuse you. Then it's got the date and time associated with that file. So then we have two things in here called table delimited, which is PDS speak for a CSV file. So what we're doing for this particular product is we're treating the first row with the headers as a table by itself, and then the rest of the file as another table, so we can describe them separately. So if you looked up the first table delimited, it's got a name. It says this is the header. It's got a local identifier. It's got some other stuff. It says this is a parsing standard of PDS BSV1. All CSV files use that. And it's got a description of the record. Inside the record, there are this many fields, this many groups, one group meaning a repeating field. And it tells you what is that group field all about. These are column headings, repeats that many times, 1,216. It's got a description, it's got a name, it's got a data type and so forth. So that's just the description for the header row. The important stuff is in the other table. I'm going to open up the second table. This is the actual spectrum, nervous raw spectrum. It's got it offset from the front of the file, because we have to skip over 5,136 bytes to get past that header and start this table. It's got 150 records in the file. They are comma delimited. They end with a line feed, and one record has 17 fields or columns and one group. That group is that bunch of spectra columns that are at the end of the file that I showed you, 1,200 things. So you don't have to write a column description 1,200 times that looks exactly the same. You can just say, I have a group of 1,200 things that are exactly the same. And it's defined here at the end with this group. Got 1,200 repetitions. I need to put a description in there. It is an ASCII integer. That should probably be a real number. Yeah, those are real numbers. Let's change that. They really ought to be real. And that will describe those 1,200 columns. And all these other things up here, these other fields, these are the column headings. There's the one heading, it's an ASCII integer, it's a spacecraft clock count. The next one is epoch time. Here, I'll show you what this is really. We're describing this column, there's ASCII acquisition time, and then there's epoch time, whatever that is. The next one is, anyway, you get the idea. So we went through and made a definition for each one of these columns. So if your software can read XML, you can read this table description and you know, jump this many bytes into the file, you can collect column data and you know what data type it is and you know what to do with it. Okay, so I'm gonna stop because I've been talking a lot. Anybody have questions? Everybody awake? Good. Let's save that. I changed it. All right. So I'm gonna go back to my slideshow. So we've just talked about file area observational. The next piece we're going to talk about is the reference list. Where do you get more information about this product? So there are basically two kinds of references in a label, internal and external. Internal reference means a reference to something that's already somewhere else in PDS. It's in a PDS archive, so it's got a lid. The external reference is anything that's not inside a PDS archive, and it can be a publication with a DOI. It could be a product from some other kind of archive if it's got its own unique identifier for that archive. So just to show you examples, we have some examples? Yes. So for the PIXL bundle, it's got internal references. Here's what an internal reference looks like. It's got a lid right there. Oops, I didn't need to do that. And it says what kind of reference this is. This is the bundle's documentation. There's another one that's another document, PIXL user guide. And then an external reference, this is one with a DOI, and it's the PIXL instrument paper. And it's got the citation there. So that's also a pretty simple thing to do. You can put in a reference to anything. Okay, more questions? Rolling along. So we've talked about 3 of the 4 parts of product observational. We've answered these questions. What product is this? Where do you get more information? What is inside this data file? And that leaves this big piece, observation area. Where, when, how, why, by whom was the data acquired? This is going to take up the most space in your label. There's a lot of stuff going on here. So do just jump in and ask questions when it stops making sense. So let's see. Inside this class called observation area, there are these 6 subclasses: time coordinates, investigation area, observing system, target identification. In this case, target means a big target like a planet. The mission area and the discipline area. We're going to go through those one at a time. And in order to talk about these 3, investigation, observing system, and target identification, I have to take another little detour and tell you what context products are all about. Remember, I said before that this part of the label puts the product in the context of what instrument acquired it, what mission was that instrument part of, what was the target of observation, and so forth. Those are context products that we're going to talk about. Okay. Context products are descriptions of those things. They're just basically labels themselves. They have been registered with PDS, and they are written by PDS with input from the people on the mission or the instrument PIs or so forth. So the registered context products are online. You can go look at them. There's the link. And you have these products registered with their own lids so that you can use the lid inside your label. and refer to the context that way. So here are the examples that we're using for Viper. We made up a mission context product that they all start, notice they all start the same way, URN, NASA, PDS context. For the Viper mission, this is the context product ID, investigation mission.viper. There's one for the spacecraft, just different from the mission, spacecraft.viper. There's one for each of the instruments. There's the nervous one in IRVSS. We talked about whether there was going to be a rover context product. I think they've decided yes, there is. And then the target is the moon. So for your missions, you will have to help us, PDS, write context products for your mission and spacecraft and instruments, but you don't have to write one for the moon because somebody's already done that for you. So what in the world do you do with them? All right, here's an example of what they're for. On the left side, here's a standard label for a science product. On the right side, this is a context product. So in the label, I want to put something that says, this product came from the Viper mission. So I have a mission part of an investigation area and what mission it was. And here's the reference to the context product. And if you take that string and go look it up in PDS and all the context products, you will come up with this one. That's the identifier. And then you can read more about the Viper mission, and you probably don't really care about what they put in this little paragraph, but what you do care about is the references that they'll list that you could put in they'll probably put in the Viper publications. I don't know what else they want to put in that reference list, but that's sort of the way of establishing the official context for this product so that everybody knows what we're talking about. 50 years from now, the poor grad student who gets assigned to this will know where to look this stuff up. Okay, I'm done talking about context products unless anybody's got questions. Okay, going along. So that covered investigation area, observing system, and target identification. Let's go look at the actual label before we go on to the dictionary parts. So let me go back up to the top of this one. Close up that part we already looked at. Here we are in observation area. Investigation area is what I just showed you. There's the Viper mission. Time coordinates, that's every science product has this time coordinate area where it's the start time and the stop time. If you don't know what the stop time is, there's a way to deal with that. But it's start time using this particular format, year, month, day, capital T, hour, minute, second, fraction. Z at the end means it's UTC time. And then we have investigation area for observing system. That's another subclass here. We've got one for the instrument host, which is the spacecraft. So there's the context product for the spacecraft. And then we've also got the instrument, the nervous instrument itself. There's the context product for that, reference to it. So that's observing system. And then finally, we have target. There's the context product reference for the moon. And that's it for most of the observation area. So I'm going to close these back up. Close up investigation, close up observing system, close up target. And what we're left with here is mission area and discipline area. So I'm going to go back to my slideshow. So you've probably heard me talk about dictionaries, that there can be mission dictionaries, and then there are other kinds of dictionaries that already exist in PDS that we call discipline dictionaries. For example, there is an image discipline dictionary that contains classes and attributes that tell you about images. There's one called Geom that has geometry information. There's one called Cart that has cartography. There's a whole bunch of them that are already in existence that you can probably use to describe your data products. And in the process of designing your labels, if you discover that you need some metadata that doesn't exist in any dictionary yet, we can fix that. We can either add it to an existing dictionary, or we might add it to the mission dictionary. I'm going to make that up. So there's a mission dictionary for each mission. That's the thing. So let's go on here. Here's an example from Mars 2020 from that PIXL label. There is this mission area in the label. That's a big class. Inside it, there is a subclass called Mars 2020 parameters. There's a bunch of subclasses inside that. Here's one called observation information, and it has these kinds of things: release number, mission phase name, the spacecraft clock start and stop, the sol number, day number, solar time, local true solar time, the sol for the local true solar time, a lot of clocks going on, solar longitude, and the flight computer, because 2020 has 2 computers. So none of these things were defined in the main core dictionary. So we made them up and put them in the mission dictionary for Mars 2020. And there's also a piece of this dictionary that's just about PIXL, and we put in the things that the PIXL team wanted to save to record about their observations. This is all part of the mission dictionary for Mars 2020. Okay, rolling along. So remember, I was doing this originally for the Viper team, and so I said, how is this going to work for Viper? Well, we might have a mission dictionary named Viper, and it might have a class called Viper parameters, and you would put some of these things in there, and you might have a class called nervous parameters. And I made up a silly example just to show you that you can put in there whatever you need. Or, it doesn't have to be. It can be things that make sense only for Viper or only for nervous. It can go in that dictionary. So when you get ready for this, and how do you actually create a mission dictionary? We will help you. We will give you we will make a draft, sort of a empty template for a dictionary definition file, and we'll show you how to write definitions. Then you can look at existing dictionary definitions that are on GitHub and that are on the main PDS website. Those are listed in the resources at the end of this slideshow. And you can get some help working on defining your own classes and attributes. And in fact, I advise you to get PDS to help you, because otherwise you'll have to make a whole bunch of mistakes before you get it right. But one way to think about it is, when you're designing labels, just use your imagination and put in whatever you think. Just make stuff up. Put in whatever you think you're going to need there. And then we will help you figure out if that already exists or if there's a better way to say it. And if you have truly something that nobody's ever needed before, we will help you get that defined. And by the time we get to the first data release for your data, that dictionary will be made public. But before that, it will just be available to you, the data providers, and to PDS, so that we can keep working on it and not make it public until the time comes. Okay. So that's the mission dictionary that I just talked about. And now let's talk about the discipline area. These are the discipline dictionaries. These are a few of them. There's like, I don't know, 50 some, right, Mitch? I don't know how many now. So these are the dictionaries that already exist that you might want to use, depending on what kind of product you have. These 3 examples are Geom for geometry, Mission Surface for landed and rover missions, PROC is for data processing information. Basically, you record the processing history if you want to. There's a whole bunch of other discipline dictionaries which we can talk to. That would take another whole slideshow for all that. And that's where they belong in the label. Okay, so I'm going to kind of back up here, I think. Oh yeah, for Viper, we tried to think what would actually go into a Viper label in the discipline area, and we decided it's just hard to tell what goes there until you have some really good examples of your data products. And it's necessary to have those examples before you can start inventing things to go into the discipline area. I think I've hit that nail before. You really need good example of data products, realistic ones. Okay, this is where we've been. We've talked about all the 4 parts of product observational. And inside this one, observation area, we talked about these 6 subclasses: context products, target identification. We talked about the mission area, the mission dictionary, the discipline area with other dictionaries. And we've done just about everything, all the parts of this label, except the mystery part at the top, those 3 strange lines that I told you not to worry about. So we're going to get there now. Don't be alarmed. You can ignore this if it scares you. This is what all this stuff at the top of the label is for. I'm just going to do this on one slide, just to forestall questions. Don't worry about it if it makes no sense. You don't have to know this now. But just for your edification, you see something in a label, we're still using the Viper example, that here's a tag in my example label that starts with Viper : and then has Viper parameters after it. That Viper there is the name of the mission dictionary. It's just kind of a shorthand for this long string HTTP PDS4 mission Viper v1. It's almost like a variable substitution. Viper means that. So what is that thing? That is the name of the, I'm going to get it right, Mitch, namespace. And for now, you can pretend like namespace and dictionary mean the same thing. So that is almost good enough to get you there, but you also have to know, where does that dictionary really live? That's what this line in the label is for. It says this namespace actually lives here in this location online. And it really does. You could actually go look it up. This thing with XSD at the end is a schema file that XML recognizes. In PDS4, every schema file comes with a partner called a schematron. It has the same name, but it ends with SCH. And that's up here in this part of the label. So there is actually logic to why this is all put together this way, but I'm not going to tell you anything more about it. This is all you need to know for right now. And so when you see all this stuff at the top, you can see that this XSI schema location consists of pairs of values, where like this is the main PDS dictionary name, and this is the main PDS dictionary location online. And for the next dictionary, this is the namespace for Viper, and here's the location online. And sometimes there could be 5, 6, 7, 8 pairs telling you where to find the various dictionaries online. Don't worry about it if it doesn't make any sense. It will. Okay, I'm sure everybody's asleep now. Okay, let's recap. This is what we just talked about. We have product observational. We have these 4 areas that tell you everything you need to know about this product, answers all these questions. And now, go back to our outline. What are we going to do with this label that we've designed? This is what we're going to talk about next. This is really brief. If I was going to go into details, that would be another whole hour spending on online to tell you about what to do with the label that you've designed. So this is just a very high level overview. You have a label design. So what do? How do you go from a design to producing real labels? You need these kind of 3 pieces. So you can imagine that you have a label template with blanks that you fill in, and you have some list of metadata that gets to fill in the blanks. And you combine them with some magic software, and out pops a whole bunch of labels. That's the general idea. So what is that? Label production software? There's no one answer to that. It could be a bunch of things. It could just be your own data processing pipeline that you put in some modules that spit out the label as you're producing your data. PDS has a few tools that will do this kind of thing, and they are listed here with their URLs. We have one here at Geo that reads a spreadsheet and a template and pops things from the spreadsheet into the template. PDS MI label, that stands for metadata injector, and its old name was Generate. So if you've ever used a PDS program named Generate, it's the same thing here. It uses a slightly different way of populating a label. And then PPI node of PDS has a thing they call DocGen, which is pretty similar to MI label. And the way they work is they use I already talked about that yet. They use a tool called the Velocity template language for populating a label. We'll get to that in a second here. So how do you get, once you've got your draft label, how do you get to an actual template? Right, suppose we started with a valid draft label, We'll use the one that I was just showing you for nervous. And you pick out what parts of the label are going to vary from one product to the next. Those are the red things that you see on the screen. So everything that's in black and white is going to be the same in every label, but the red parts are going to change. And then you replace those things that are going to change with variables. So like watch, where my cursor is, watch the red part of the logical identifier. See, it's going to be replaced with a variable or placeholder. And similarly, the other red parts will be replaced with placeholders. They don't have to have this syntax. I use this because that is what the velocity template language likes to see. You could use whatever syntax for a placeholder your software likes to see. This is the standard one for velocity. And the other thing about velocity is this can be a lot more complex. It can incorporate some Java and some conditionals and all kinds of weird things. That's the basic idea. So if you've got a label template like we just made with some blanks, placeholders to fill in, and you've picked out what production software you're going to use to make your labels, you need a third piece, which is the metadata for filling in the blanks. And what is that? That can be a bunch of things. It's sort of application dependent. You could have a spreadsheet, a CSV file. You could have your database that your pipeline software can read from. It kind of depends on what software you've chosen. Any questions about this? This is the very high level view. All right, we're getting close to the end. So the last piece, once you've got your batch of labels, is you validate it. I'm not going to talk a lot about validation here because that could be another whole slideshow. There is a validate tool that PDS makes available. It's at that link. You are required to validate your products before you deliver them to PDS. So this helps you because if you don't do it, we will, and we will find your errors and make you fix them. So it's best that you do it yourself before you deliver. You send us the validation report. And then we're going to run validate anyway, just to make sure. And it checks a lot of things. One thing that's new in PDS4 that we didn't have in the old PDS3 is validate can actually look inside the data file and make sure that you have correctly described everything in there. Like if you have 12 columns in your table, but your label only describes 11 columns, validate will catch that. If you have the wrong data type for something, you'll probably catch that. If your image is not the same size as you say it is in your label, it will catch that. Those kinds of things. So we'll actually look inside the data file to see if the label is correct. PDS3 never did that. We will also check that your label follows the rules in the dictionary and in the other dictionaries. Do you have things in the right order? Do you have the right required attributes? And are you using the optional ones correctly? We'll check your collections and bundles. Those also have labels to make sure that they are correctly describing the collection in the bundle. And do your labels correctly refer to the context products? There's a bunch of other stuff that validate does. And we will help you install it and teach you how to use it and get the right dictionaries available so that validate knows where to look to find all that information. That's really all I'm going to say about validate right now. Okay, here's where we are. The last slide is just references. Where do you find more information about all this stuff? PDS Data Provider's Handbook is a sort of a cookbook style, big picture guide to preparing an archive, not just labels, but the whole archive, more or less in the order in which you would want to do things. The small bodies note of the PDS has a wiki with very good, very detailed instructions that actually explains things more detailed than I wanted to know, but they're very thorough. And I recommend that you'd start with a big picture in the Data Provider Handbook, and then for specific questions, go to the Small Bodies Node Wiki. The PIXL archive that we were looking at, the example is online there, if you want to go check that out. Context products for PDS are here, if you want to see what other people have put in their context products. The dictionaries are in 2 locations. The main PDS dictionary, the discipline dictionaries, all the mission dictionaries are available on the PDS website here at this location, and they are also on GitHub. You can download them from either place. When you start working on a dictionary, a new one, or you want to revise an existing one, we'll do it on GitHub, and we will have versions that are just available for people who are working on it, they won't be public until we decide to make them public via GitHub, and then they get listed up here on the website.